In this video, we're going to have a look at the process of rationalising the denominator. So when there's a surd in the denominator of a fraction, it's difficult to estimate the value of that number. With the aid of calculators, it's not so hard to do anymore, but we're going to have a look at the process that we do to rationalise the denominator. And basically what we're doing is making the denominator an integer or a rational number. So the calculator makes it a lot easier. They're a lot more powerful these days if we just plug it all in and estimate the value. But we're going to have a look at the process behind it. So when the denominator of the fraction is a simple surd, for instance 5 over root 3, then to make that denominator a rational number, we have to multiply it by root 3. But we can't just multiply the denominator by root 3. We've got to do the same with the numerator. In other words, we're going to find equivalent fractions. So we're just multiplying it by 1 in reality, but we're going to have a look at what it looks like once we change it. That way we don't want the denominator to be a surd anymore. So let's take 5 on root 3. And as we said, we're going to multiply it by root 3 on root 3, because that's just 1. So what we now do is when we multiply fractions, we multiply the numerators together, and we multiply the denominators together. So we get 5 root 3 on root 9, and remember, we know what the square root of 9 is, that's just 3. So what we've now done is changed a fraction with a surd in the denominator to now a rational number in the denominator, in fact an integer in the denominator. I don't care about a surd being in the numerator, it's the denominator that I'm worried about. And that's it. So when it's a simple fraction like that, just multiply by root 3 on root 3. So that denominator determines what we multiply by here. So let's look at another example. Let's make the denominator a little bit more complicated. Again, I don't care about the numerator. I don't care if it's a surd or just an integer or an expression. It's the denominator I'm worried about. So I've got 2 root 7 there. Now I could multiply by 2 root 7 over 2 root 7. And then we're going to find that that fraction will actually simplify. So an easier way is just to multiply by root 7 over root 7. But just be careful of this approach, because later on when we look at more complicated denominators, we've got to be careful what we do multiply by. So there's the question. We're going to take that and multiply it by 1, root 7 on root 7. Again, multiply numerators together, and then multiply denominators together. As I said before, we could multiply by 2 root 7 on 2 root 7, but the fraction will then simplify. So numerators, root 35, denominators, 2 root 49, and we know the square root of 49 is 7, so 2 lots of 7 gives us 14 in the denominator. So now that denominator is a rational number. And that's it for that particular question. So let's make them a little bit harder. What happens if the denominator is actually an expression with a surd in it? So we've got a minus or a plus in there to make it an expression. Well, what we have to do is multiply by that same denominator except opposite sign in there. So we've got a minus sign here, so we've got a plus sign there. It's important we do that because then we're going to have the surds eliminate when we expand it out. So this opposite sign in here is known as the conjugate surd. So root 3 minus 2, and its conjugate surd is root 3 plus 2. But again, the numerator has to be the same, and that way we won't end up with a surd in the denominator when we do this. So there's our question. Let's multiply it by root 3 plus 2 over root 3 plus 2. Remember the opposite sign. Multiply numerators together, so root 5 times root 3, and then root 5 times 2. So we get root 15 plus 2 root 5. And then we multiply our denominators together. So root 3 times root 3 is root 9. Root 3 times positive 2 is positive 2 root 3. Negative 2 times root 3 is negative 2 root 3. and negative 2 times positive 2 is negative 4. Now once we've done that, let's simplify what we can. The numerator won't simplify, but the denominator will. So square root of 9 is 3. Positive 2 root 3 minus 2 root 3, they cancel out. And then we've got our minus 4 in the end. So 3 minus 4 is negative 1. Now normally we don't have 1 in the denominator, so I'm going to share that negative with the 2 terms up in the numerator. So I now get negative root 15 minus 2 root 15. And what we've now done is just change that fraction with a surd so that there's no longer a surd in the denominator. So let's look at a couple of harder examples. So we want to write this expression with a rational denominator. Again, I'm not too worried about the numerator, it's the denominator I'm worried about. So let's start off with that question and multiply it by the conjugate surd of this denominator. So same terms, opposite sign. So same terms, opposite sign. Now we have to multiply the numerators together. Remember, using our FOIL method if that's the way you prefer. Multiply the firsts, so we get 5 root 9. Multiply our outers, so negative 10 root 15. Multiply our inners, negative root 2 times negative root 3 is negative root 6. And then multiply our lasts together, which is positive 2 root 10. Then we expand our denominators, root 9 minus 2 root 15 plus 2 root 15 minus 4 root 25. Once we've expanded those out, let's simplify our numerator. Remember, root 9 is 3, so 5 3s are 15, and nothing else simplifies in the numerator. And the denominator, these two terms cancel out. And I've got 3 minus 4 lots of 5, so 3 minus 20. And then I can now just simplify the denominator. 3 minus 20 is negative 17. Sorry. So a harder example, but the process is still the same. Remember, if you're not so good with multiplying surds, then see the previous video of mine. Let's have a look at one last example. Evaluate as a fraction with a rational denominator. This time we're subtracting two fractions. When are you allowed to add or subtract fractions? Well, when the denominators are the same. So we need to make these denominators the same. So here's our question. What I'm going to do is, to make the denominators the same, is multiply this denominator by this one. But remember, equivalent fractions, so I've also got to multiply the numerator by that same expression. And then the same over here, I'm going to take this denominator and multiply it by that one. And then that means I've got to multiply the numerator by that as well. So let's go ahead and do that. So here's our first fraction. I'm just taking this denominator and multiplying it by both the numerator and denominator. Then take away, here's our second fraction. I'm multiplying both the numerator and denominator by this denominator. So what we can now do is expand out the numerators. So 15 minus 5 root 5 minus 3 root 2 plus root 10. I can bring them all together as one particular fraction, but be careful, I'm subtracting all of that numerator, so that negative 3 root 2 take away another root 10, so that's why these both become negative. Just be careful, if this was a negative, so take away a negative would then make that a positive, so just be careful with those. I can't simplify any of the numerator, but what I can now do is the denominator still has surds in it, so I'm going to expand that out. So 3 times 3 is 9, minus 3 root 5, plus 3 root 5, minus square root of 25. That's 3. So that's still 9. These cancel, and this is 5, so take away 5. And then 9 take away 5 is 4. So what started off fairly complicated is now with a rational denominator. The expression in the numerator is fairly long and complicated, but it's a lot easier to understand than what we've got written there. So I hope you found this useful, and what we now need to do is practice, and then practice again, and then further practice to make things a lot easier for you. So the more you do these, the easier working with surds becomes. So I hope you found this video useful, and share it with others if you think it's going to help them also.